A very good morning to all of you. I am Dr. Harsha Chatrath and I am going to speak on Ionic Equilibria and buffer solution. In today's presentation, we are going to discuss about the Ionic Equilibria and buffer solution, how they are related to each other, what is buffer solution, how buffer solutions are prepared, what is their importance in the general life. So let's discuss what is a buffer solution first. Let's understand how is it prepared. Buffer solution is a solution which resists large change in pH on addition of limited amounts of acids or bases. Limited amount means very small calculated amount. We cannot add large amounts of the acids or bases because the pH cannot vary from more than 0.1 to 0.2 digits from the original value of pH of the solution. So the pH has to be maintained constant. For this purpose, we have to add amounts of acids or bases. So the buffer solutions are prepared by adding either weak acid with its conjugate base or weak base with its conjugate acid. Now, what is a conjugate base? Conjugate base is that base which removes hydronium ion. Hydronium ion means H3O plus, which is prepared or which you get in the solution when lots of protons are present in the unreacted protons are present in the solution and they go and get attached to the water molecule forming hydronium ions, and these hydronium ions they react with the negative addendum and they again get converted to acid and water. Now, what is a conjugate acid? A conjugate acid is an acid which removes excess of hydroxyl ions present in solution. So, from where do you get hydroxyl ions? The hydroxyl ions obtained from the base. So, these hydroxyl ions react with the acid and they give negative addendum and water is liberated. That means excessive amount of water is present in the solution. So, due to the presence of excessive amount of water, you can maintain the pH. This does not mean that dilute solutions are buffer solutions. Buffer solutions are those solutions which can absorb addition of acid or bases with only slight change in their pH values. These are actually the combination of a weak acid with weak base having one of its own salt. For example, you have acetic acids and sodium acetate. Sodium acetate is a weak base because acetic acid is a weak acid. So, sodium acetate is a salt of this weak base. Therefore, such combinations are used as buffer solutions. Ammonium hydroxide and ammonium chloride. So, this is another example of buffer solution. This is example of basic buffer. Is it clear to all of you? So, we have got this example over here that when pH of water is 7 and it is added to a pH of an acid with 4, the overall pH of the new solution is 10.5, which is a very high pH. But if this water is added to another acid of pH 6.9, then in that case the new solution which is formed has got a pH of 7 only. So this is a buffer solution. So buffer solutions are very essentials, and we have to maintain the pH of the solution. Buffer, what is the mechanism of buffering? That is very important. Here you can see in these diagrams over here, you have got hydroxyl ions, they react with the acid and they give you A ions and water. Now the hydroxyl ions, they are reacting with the acid and they are giving you A ions, which are shown by purple color, and water is shown by the blue color. Now the amount C is very less. It is not that vast amount of the acid ions or vast amounts of the water molecules are present over here. So there always exists an equilibrium between the hydroxyl ions and A ions and water and acid molecules. We can take the example of hydrochloric acid and A ions over here. When hydrochloric acid reacts with the ions conjugate base, and it gives you the acid here, Ha, and also a basic ion over here. So similarly, there you have, this is shown over here. See, there is not much difference in the number of ions and molecules present in both the cases. Example is HCl. Here there is an equilibrium. Always an equilibrium exists. This HCl reacts with water molecule to form hydronium ion and liberates chloride ion. HCl also reacts with the A ions to form Ha and chloride ions. So ions are liberated over here. So the chloride ions, they are dissociated from the HCl and they are liberated in the ionic state, and these ions will again react or absorb the protons which are liberated by the hydronium ions and reconvert into the HCl. So this is the reaction which is going on, and this is the case if we mix weak acid with its conjugate base, and this is only takes place when both the acids are weak and bases are not very concentrated. So in case of concentrated acids and concentrated bases, buffers do not form. Due to the high concentration, they undergo proper reaction, so pH value changes drastically. Case of weak acids and weak bases, the acids and bases, they remain in solution, and since they only rarely react with water, therefore they remain in the solution as such. Therefore the pH does not change. This is the mechanism how a buffer works. See, this is your acetate ion, acetic acid, acetate buffer. This is sodium acetate and acetic acid buffer. This is buffer, conjugate acid and base are there. Now if it reacts with hydronium ion, it will be converted into acetate ion and acetic acid. Water proton from here will react with the acetate ion and it will convert into acetic acid, and again you will get another acetate ion. Here if it reacts with again hydroxyl ion, in that case also you will get the acetate ion and acetic acid. So this is a buffer, whether it reacts with hydronium ion or whether it reacts with hydroxyl ion, the product is always same. So in this case acetic acid is formed when it reacts with hydronium ion, and when it reacts with hydroxyl ion it gives you acetate ions. So the concentration remains same. If the concentration remains same, pH will also remain same. There are two types of buffer solutions, acid buffer and basic buffer. The acid buffer has a pH value less than 7, and basic buffers have pH value greater than 7. Acid buffers are made up of weak acid and salt of its conjugate base or salt of a strong base. For example, acetic acid and reacts with sodium acetate. Sodium acetate is formed when sodium hydroxide reacts with acetic acid. It forms a sodium acetate. Sodium acetate is salt of a strong base, sodium hydroxide, and acetic acid is a weak acid. This is called acid buffer, acetate buffer. And here parent acid is acetic acid. It has got a loosely bound proton over here which reacts with the water to form hydronium ion, which is its conjugate acid, and the ion which is liberated, that is acetate ion, is the conjugate base. Similarly, when we talk about basic buffers, at that time in basic buffers they are made up of weak base and salt of conjugate acid or strong acid. Now example is again ammonia and ammonium chloride. Ammonium chloride is made up of ammonia and hydrochloric acid. Hydrochloric acid is a strong acid. It reacts with ammonia to form ammonium chloride. So ammonium ion is conjugate acid and weak base is ammonia. Again, here ammonia reacts with the water in which it is dissolved to form ammonium hydroxide, and this here ammonium hydroxide is formed. Ammonium is a conjugate acid and hydroxide ion is conjugate base. Again, this ammonium hydroxide dissociates to give ammonia and water. So for this, ammonium is acid, hydroxide ion is base, but now it has got conjugate base ammonia and conjugate acid water. So for each acid and base there is a conjugate acid and conjugate base which reverse their reactivity when their reaction changes, reversible. When the reaction reverses, their action also changes. From normal it becomes conjugate. Okay, is it clear to you? Now we have this another example of it's now we know that we have got two types of acid buffers, acid buffer and basic buffer. So as we have already discussed over here, the nitrous acid and water present in it, acid base is water. So it gives you conjugate acid is proton and conjugate base is nitrite ions. So these ions, when they react together, it's a reversible reaction. Then at equilibrium we have the values of ionic constants. At equilibrium is given by the concentration of protons and concentration of nitrite ions divided by the concentration of nitrous acid and concentration of water. Now concentration of water always remains constant, therefore it is 1. Hence it is the ratio of at equilibrium the value of the ionization constant is equivalent to the value of the ionization constant at given concentration. So it will be equal to the activity of proton into activity of nitrite ions divided by the activity of the nitrous acid. So this is the way we can utilize the ionic equilibria constants to find out the concentration, and from the concentration, if the concentration there is not much change, the pH will remain constant because concentration is inversely proportional to pH. Therefore the pH remains constant, so solution will be known as buffer solution. Otherwise, it will be known as normal solution. Another example of buffering is ammonium hydroxide and ammonium chloride. Ammonium hydroxide dissociates to give hydroxyl ion and ammonium ion. Ammonium hydroxide is a base and ammonium ion is conjugate acid. Again, ammonium chloride gives the chloride ions and ammonium ion. Now, ammonium ion is an acid. It reacts with the hydroxyl ion, which is base, which is obtained from water, and it is converted to ammonium hydroxide. And the ammonium ion, which is obtained from ammonium hydroxide, reacts with the chloride ions, which is obtained from ammonium chloride, and it is converted to ammonium chloride. So this is another buffer solution. So buffering capacity shows that they have got a common ion effect. One of the ion should be a common ion, due to which the concentration will remain constant and it will act as a buffer. Now we have seen that there are two types of buffer, and a third type of buffer is a neutral buffer. Neutral buffer means the buffer whose pH is 7, and this neutral buffer is, example is water. Normal water, tap water is a neutral buffer solution, or the water from aquaguard is a neutral buffer. Sea water is not neutral buffer, it is alkaline in nature. So you have got certain examples. The neutral buffer is 7, 0 to 7 is acidic, 0 is the highest, 1 is highly acidic, and as we move towards 7, the acidity decreases, acidic character decreases. And then from 8 to 14, 7 to 14 is the basic character, the 7 from 7.1, that is 8 is the weak basic, and 14 is the strong base. And the example of pH 14 is liquid drain cleaner. So these are the different examples of different pH, and the value of pH is very important. So we have seen that the buffers are of very important. We have got different types of systems in the universe, the living system and non-living system. The living systems basically consist of human systems, animal kingdom, plant kingdom, and these systems, they have got their own pH. If they want to survive, all the systems have to maintain their pH. If the pH does not remain constant or pH varies drastically, plants die, humans die, as well as the animals are destroyed. So everything is based on the pH. Every system has got their own metabolic reactions, and these metabolic reactions or these body functions are dependent on the narrow pH ranges. If the pH range goes very high, in that case there will be a total destruction. So chemical substances, they neutralize the small amount of acids or bases when added to these systems and maintain the pH ranges of these systems. And these buffering systems, they always maintain the pH values, as a result of which the universe is surviving. For example, we can take our own case. In our case, the pH of blood is 7.4. The variation scale of pH of blood is between the value of 6.8 to 8. So, if the value goes below 8 or above 8, death is inevitable. So to keep ourselves healthy, the pH value of our system should be in around 7.4. Is it clear to all of you? If you have any questions, you can ask me. I am always available for you. Okay. Thank you for patiently listening.